Unit 10, Lesson 3, Describing Geometric Patterns. As you can see, this title is very close to Lesson 2, which was Describing Number Patterns. What is the difference between geometric pattern and number patterns? You will see that we can transfer the geometric patterns to number of patterns, and after that we use Lesson 2 as before. So the trick here, how to transfer the geometric patterns to number patterns, and after that what we learned in Lesson 2 we'll repeat it again. That's why this lesson is very easy. So we are saying the perimeter, the area, or the number of shapes used to build a growing figure pattern form a number pattern. This word is very important. If I have a geometric pattern that it can form a number pattern, that means all I have to do to transfer this geometric pattern to number pattern, and after that I use what I learned in Lesson 2. We are saying the nth term. In the previous lesson we are saying nth term. Now we call it nth frame. Why frame? Because it's geometric, there is a shape. And after that, to describe or extend these growing geometric patterns, we can also use the table, the graph, and the algebraic expression. Again, we can use the same strategy that we used before for number patterns to the geometric patterns, so it's the same. Again, we're gonna say the table, it's good for small numbers. The graph, it's not perfect, because if my graph is not perfect, the result is not exactly, so the algebraic expression is the best. So let's start to introduce an geometric patterns. So we will see this example. It's a good example for geometric expression. Frame 1, can you see? We don't say term 1, we say frame 1, frame 2, frame 3, frame 4. The best thing that we can do is to transfer this geometric pattern to number pattern. So we are saying the perimeter or the area, it could be a way. So let's count how many tiles here as a perimeter. You will see 4 and 4, 8. You will see 3 and 3, 6, 8 and 6, that means 14. So right away I can go and I can write right away the frame number and the number of tiles. So now I saw that the number of tiles, it's 14. In which frame number? Frame number 1. Excellent. I go back to the drawing. I will notice something, that now instead of 4 and 4, 3 and 3, I have the 3 and 3, but this time I have 5 and 5. 5 and 5, 10, and 6, 16. So right away I'm gonna write that in frame number 2 I have 16 tiles. Excellent. I go back, frame number 3, I have the same thing, 3 and 3, and this is very important to notice the 3 and 3, okay? I will tell you why after. So 3 and 3, which is 6, but this time instead of 5, it's gonna be 6. 3 and 3, so 6, and 6, 12. 12 and 6 means 18. So frame number 3, we have 18 tiles. Next, again, I have 3 and I have 3, so I have 6. Then here, 1, 2, 3, 4, 5, 6, 7, so 7 and 7, 14, 14 and 6, right away it's 20. So frame number 4 is 20. This step, yes, it's a strategy, a table, that it works with geometric, but it's gonna help me to transfer this geometric pattern to number pattern. So I have 14, 16, 18, 20, this is my pattern. Now, how can we transfer this to algebraic expression? This is what we learned in lesson number 2. So I'm gonna use the same thing here. I have 14, 16, 18, 20. I'm gonna write this value, 14, 16, 18, 20. And the term number here is so easy. It's 1, 2, 3, and 4. And we call this frame number. Excellent. Now, I will do exactly like lesson 2. I want to check how to get from 14 to 16. I need to add 2. From 16 to 18, I need to add 2. From 18 to 20, I need to add 2. This repetition of 2, it helps me to find the algebraic expression, and this is my goal. That means we said usually it's 2n, and after that I can modify. So let's start with n equal 1. If I'm saying the algebraic expression 2n, that means 2 multiplied by 1 is 2, but I have 14. That means I need extra 12. So I need to modify the algebraic expression to something like that. Hopefully it's gonna work with all the value. So n2, n equals 3, n equals 4. If it works with this 4, that means my algebraic expression is totally right. So let's start. 2, n here is 1 plus 12. 2 times 1 is 2 plus 12 equal 14. Correct, I have 14. Nice. Next, 2 times n is 2 plus 12. 2 times 2 equal 4. 4 plus 12 equal 16. Nice. 2n, n equals 3 plus 12. 2 times 3 equals 6 plus 12, 18. Do I have 18? Yes, nice. And the last one, 2n, n equal 4 plus 12. 2 times 4, 8. 8 plus 12 equal 20. Do I have 20? Yes. Excellent. So my algebraic expression is correct. So in this case, let's say in this drawing, the question find frame 100. Can you imagine that teacher can tell me find frame 100? How many tiles do I have in frame number 100? How many tiles? Or how can I draw the frame number 100? How to go from 4 to 100? Right away, I'm gonna use algebraic expression. This is the easiest way. So with table, it's gonna be hard. With graph, it's gonna be not perfect. So the algebraic expression is the perfect one. So let's say I need frame number 100. So I will write n equal 100. That means 2 times 100 plus 12. 2 times 100, 200. 200 plus 12, 212. Wow, I got right away how many tiles I have in frame number 100. So I go back here and I say I found it. There is 212, sorry, not frames, tiles. 212 tiles. Excellent. Now the question is how to draw it. How many tiles up, how many tiles down, how many tiles in the left, how many tiles in the right. As you can see here, if you remember at the beginning, I told you very important to note that there is 3 and 3. Again, 3 and 3. Again, 3 and 3. That means what? That means this 3 in the right side and the left side, they are standard. So I can say, okay, this area I have 3. And this area I have 3. Now I need to know how many frame do I have here, how many frame do I have here. If I have a total of 212, I have 3 and 3. That means I can come from the 212 and I remove 6 tiles. That means 206, it's gonna be the total of this and this. I divided by 2 to get how many up, how many down. So 1, 0, 3. So 2 times 3 equals 6, 2 times 0 equals 0, 2 times 1 equals 2. So 103 up, 103 down. This is to give me 206 plus 6, 212. Done. I found the frame number 100 with small calculation, but this was the principal number that I got it from the algebraic expression. That's why I told you this lesson is very important, how to transfer the geometric pattern to number pattern. And after that I use what I learned from lesson number 2. Let's see another example. This one. As you can see, it's very simple. Frame 1, frame 2, frame 3, frame 4. Again, at the beginning of the lesson, we said what? We said we can use perimeter, we can use area, we can use the number of shape to transfer it from geometric pattern to number pattern. So let's do that here. If I come to frame 1 and I say, okay, let's talk about the perimeter. I have 1, 2, and 3. Here I have 1, 2, 3, 4, 5, 6. I count between 1 dot and 1 dot. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, so that means I can transfer the geometric pattern to number pattern. So let's go to this one, and I can use frame number tiles. So let's do it again. I'm going to use a blue color, and I'm going to say frame number 1, 2, 3, and 4. I have 4 frames. The first frame, if I go back, I have 1, 2, and 3. So the perimeter is 3. Frame number 2, I have 1, 2, 3, 4, 5, 6. Excellent. So I can come and say 6. Next, what do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent. So I have 9 as a parameter. And the last one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If someone asks me what are you doing, I'm counting from dot to dot. This is 1 unit. So as you can see, I have 4, 4, 4. That means 12. So I go to this one and I say I have 12. Excellent. If I transfer this one to the term and value to find the algebraic expression, it's easy. So I can say 1, 2, 3, and 4. I had 3, then 6, then 9, then 12. Here right away you can imagine the change right away from number to number. It's easy to find it that I'm adding 3 each time. Starting from 3, I'm adding 3 each time. Right away this is gonna help me to find the algebraic expression. So 3 and this is my algebraic expression. Hopefully it doesn't need to fix it. So let's start. I have term number 1 is 1. 3 times 1 equals 3. Wow. So I don't need to add anything or to subtract. Let's see the others. It's gonna work or not. So 3n, that means 3 times 1 equals 3. Actually the 3 matching with the 3, nice. N equal 2. Let's see it. 3n, 3 times 2 equals 6. Wow, 6 and here 6, that means it's matching. So that means the algebraic expression is only 3n. Let's go for n equals 3. 3 times 3. 9. Is 9 here? Yes, 9 is here. Excellent. So as you can see, the algebraic expression very easy in this part. N equal 4. 3 times 4 equal 12. Is 12 is here? Yes, nice. So algebraic expression is 3n. Let's see the question here. If the teacher asked me to find frame number 40, frame 40, how many, or how is the parameter here? So how can I find from 4 to 40? How can I jump? I don't have a choice. I can use right away the algebraic expression. So I'm gonna say if frame is 40, that means 3 times 40, that means 120. I have 120. If you look to the shape here, you will see that these shapes are equilateral. So 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. That means for 40, and actually there is a big relation here, it's nice relation. When the frame is 1, the side is 1. When the frame is 2, the side is 2. Can you see? When the frame is 3, it's 3. When the frame is 4, it's 4. That's nice. That means in this one, I will have 120 in total. Divide by 3, it will give me 40. That's why it's gonna be an equilateral triangle with 40, 40, 40. The 3 together, they give me 120, and this is the shape it's gonna be. So I can predict right away in frame 40, it's gonna be an equilateral triangle with 40, 40, 40. From where did I get that? From the 120. From where I got the 120? From the algebraic expression that I found it, which is 3n. So as you can see, this lesson for geometric pattern, I don't have a choice. I have to switch the geometric pattern to number pattern, then I can use whatever I know from lesson number 2. If I can use a table, if I can use a graph, if I can use algebraic expression. But again, algebraic expression is the best, because if I'm facing a large number like frame number 100, frame number 200, with the table it's going to be very long, with the graph it's not going to be perfect, so the best way is the algebraic expression. I hope you understood this lesson, and next one is going to be Unit 10, Lesson 4. Thank you.